Hey everyone, hi. So we are back with another video. So I thought that I'm going quite fast, so I thought to let's complete the basics first, and I want to see what I say your happy face. So because this is what I need before we proceed further in game development. Okay, so the topic of today, as I said, is understanding GDScript. So as I said, GDScript is the one which we use by default in the Godot engine. So we can have C hash and C++. To be honest, I don't know them. Uh, yeah, I thought I've decided that I will go with the GDScript, and that's what I'm going to work on. Okay, so what we will do is we will see the following topics today, and I have a good session on this Delta. And if you have heard FPS a lot of time in the games, we will be discussing about this also very quick. So what I do is, now let's go back to the code. Now what I will do is, let's go back here. So first thing is, as I said, we have to start getting with the code, right? Now to get started with the code, first thing is what you have to know is just click on this plus. So this one icon which you see is where it attaches the script, and in those script is what you are gonna write the GD script. So okay, now here's the thing. So you can attach your script to any of the parent or its child. So what we will do is, let's attach this script to the child. Okay, now let's call it as frog, or sorry, GD image is what we are currently using, and let's keep it like this only. Let's not touch anything. And this inheritor is what it inherits the properties of sprite 2D. If you see, uh, if you control click, you will see the description details of that. I will show you also in the coming time. So what I do here, let's keep it as GDBot, because GDBot is what we are using the image here. So let's create here. Okay, now two things here. We have attached the script, so as you can see, the plus icon shows here. Okay, and now if you attach the same script here, uh, and like let's call it as fire. So here, as you can see, you have created two GD scripts, one for fire. So basically this will affect the whole node, and one is for GD bot, it will only affect for the sprite. Okay, so as you can see, as soon on the extend, it shows what it extends to. Okay, now talking about what first we see here is basically the ready and process. So this might, even if it's confusing you, now let me just clear things for you. Okay, so whenever let's say you write a print, and you just write ready here. Okay, now the same print, if you write here and we write delta, or let's not call it delta, let's call it process. Now see what happens here is, now if you try to run it. So one more note here, one more learning point I will say. If you want to run the whole project, you have to click on this play. And if you only want to run the current scene, by current scene I mean the one which you have, which you are active working on. So currently my mouse is on this, so I'm working on fire. So this is what it will run. Okay, now if we go to our sprite, I think we have not selected an image. So let's go ahead and select an image. Let's quick load. And now let me just, or let's drag and drop directly. So this is what I'm dragging here, and yeah, we have that image. Now if you want to go to the image and edit it, you can go to the click, and yeah, it's in the center. Now what I do is, now if I preview it while my game is running, let it be like that. I close it very quick. Now if I show you, the delta only, sorry, the ready process only ran once, right? So I just click on my script, the this ran only once while the process kept on running. So this is what, so this, so the game movement, whenever you play a game, right, every movement which you make creates a frame. Okay, so this frame keeps on running. So this is what, how you see, like things are moving. And while this ready prints when the this node which you see, right, gets called, or it's present in the scene tree, and it will only runs like whenever the node enters the scene tree. Okay, like let's say you remove it and then you re-add, then again it will fire. Okay, because you have re-added into the scene tree. Well, now we have completed the ready and process. Now let's talk about how to assign variables, right? So uh, to assign a variable, let's say there are two ways to assign variable. So first is var. So var, let's say, let's call it, let's go with this GD word better. Okay, because we are going to move this image, so we are going to the this image one directly, we are adding a script to the image. Okay, so what I do is, let's create a pause, and to add a type to it, let's say what the type is. So the type will be a position, and a position has what? A position has an x and y coordinate. So if you see, select the sprite 2D, and if you go to this, you might see whatever, like whenever you have two coordinates, right? It is nothing but it's a vector type. Okay, now what we will do is, um, we had to provide a vector to it. So if I click vector 2, it will be of type vector 2, and what I will do is I will provide it a vector 0 position. So you can write like this, 0 comma 0, or you can just directly write dot 0, which will be nothing but it will be at position 0. If I go to my 2D, I can see my script is at 2D, and yeah, it's at 2D. Now one more thing here is, you might have noticed when we play the current scene, it comes at very corner, right? So the reason is because you have added at the correct coordinate, but you might see, I don't know if you can view it or not, there is a line, blue line, which covers this whole box, right? So this whole box is the reason why you see at the very end. Now if I put it here, or let's say here, okay, you might see this blue line, right? So this is where your whole game will run on. It's the resolution. Now if I play it, it will come here. That's good. Okay, now we can debug it. So now if I go back, I have a very bad habit of clicking VS Code every time. Anyways, so we have moved our node. Okay, and when we move node, remember all the childs with it also will remove. Okay, now let's go back to the child, and we have provided a position. Now if what I do is I want to change the position of this node. Okay, so how I do that is, if I click on this sprite, we can see that there is no position right here. But if I click on this node has that position, and anything inside it will will also move. So we have something called x and y. So we got it. Okay, this is a vector. Okay, now what I do is, if you hover over it, you might see the property name. So the property name is what? Position. So what I have to do is, in the like if I type position, and let's say if I make it to uh, let's say mm, let's say I move it by what I say. Let's say I set it to pause, or I can do is I can make the position to move uh, like 100 by 100. Now this will keep on running. Now if I play it, every time it will be running, every time, but you might see it at the same position, right? Because it's in the process, it's keep on running, but it's not moving. So let's say, how can we move it? So what I do is, every time what we can do is we can change the this position, and let's say we can change this position dot x by what I say, plus 10. So you add a plus here, right? And this pause is what we are going to assign here, right? And yeah, let's keep the pause dot y as it is. Now if now this time we see, well, it's moving now. So you saw that we have incremented the 10 every time, the position from 10 pixels, and at the y it's as it is 0. So that's why you saw it at the top. Now now since we have completed what I say assigning pause, now the next thing is the const variable which we have. So const variable are, let's say, like the speed, right? Which are not going to, which we are adding it as constant. So means you can write it here, but if you try to edit the speed equals 10, that time the compiler, like, this will it will not like it, and it will show you that since it's a constant we can't change it, right? And now the script will work as it is. Now if I play it, yep, so at the y it's zero axis, but yeah, but it's moving at x by 10 pixels. Now adding script to nodes is what we have looked. Now let's see for custom functions also. So currently we have talked about inbuilt functions also, as I said. So these are some inbuilt function. If you want to know some more inbuilt functions, you can always type func, and like this you can see these all are inbuilt functions, and we're going to talk about some of them in the later on videos. But I thought to, because since these two are the ones which you might see every time, so I thought to clear things for you right now. Okay, now let's add a if condition. So if the if condition is also like that only. So let's say, if you want to add a if condition, let's say if the pos dot x is equals to, let's say, 40, that time what we will do is we will, like, let's say we will remove this. So what I will do is self dot q free. So this, what this q free will do is it will automatically destroy it from the node, from the scene tree. So so if I click on this, so it plays and it disappears, right? You saw it plays and it disappears. So this is what happens. So it met the condition and it came up. Now let's talk about for loops. So how for loops work is, let's say we defined a variable, and let's say we have weapons. Since we're talking about games, let's talk about weapon. So in Hindi we call talwar. You might know what talwar is. Talwar is like a sword, right? And let's say then you have a gun, okay, and then you have a lollipop. I don't know why I use this, but yeah, lollipop can be a weapon. Totally depends upon how you use. Anyways, so we have this array, right? Now this array is what you can also define the string. What I say, this type also. Now, one more thing, why I suggest to use this type is because, let's say, if you use weapons dot, you can get all the array methods, right? But it's always best to assign it. So sometimes if it doesn't suggest you, you can say, okay, this is an array, and you can define what type of this array is. So it's an array of strings. Okay, so now what we will do is, now we will loop over these weapons, right? So instead of doing it here, because since it will be looping every time process, it's always good to do it inside the ready. So what we will do is, for I, just like in Python we do for I in weapons, okay, what we do is we print the I. Yeah, that's it. Okay, now if I play it, let it play. Now let me just close it. Now if I go here, all the array it looped over. So yeah, it's working. Now let's talk about some other things. So changing node props. Okay, now let's talk about something this also. So before we go into the node, it's always good to know how we can get the node. Okay, so there are two ways to get the node. So as you can see, let's call this node, let's say, let's say we want to get this node, right? So what I want is, whenever I get this node, I want to rotate it. So if we go, let's see, if we have the rotation here, we have something called rotation, and if we hover, the property is rotation. But if you see, it says that if you want to use degrees in the script, you can use rotation degrees. So what I do here, it's best time to use const. So I use const, and I say rotation, how much rotation you need, rotation degree. I sometimes my grammar is really bad, sorry. Okay, so degrees is equals to 90. Cool. What we will do is, as soon as the game starts, I will make sure that it moves rotated, right? So let me just remove this for loop very quick. What I will do is, um, I want to get this node. Okay, so there are two ways to get the node. You can just type get node, and if you do this, you might see all the nodes which you can pass it. But currently, I can see it's not showing any of them. because because it's currently not showing. Now let me just do the same here. Oops. I'm just checking why it's not showing here. Okay, so here it shows. So this is how it will show, because this one is the current one and sprite 2D is what we have. So since we want to change what a rotation of what we want to change rotation of the node, right? So here if I do this, I can get the node directly. So if I go here and if I type get node and if I do here, see I'm only getting this because I'm down the tree. So I'm at the this one GD board is nothing but sprite 2D. So what I want to do is I have to change it here. Okay, I want to change, I want to rotate it here. So what I do is uh, I get the position. So instead of writing here, let's do it at the what I say at the node level. Okay, now what we will do is, and from here remember that you can access, since we are at this point node 2D, so you can access sprite 2D also. So what I can do is, let's say in sprite 2D do we have anything more to change? No, I think this is good. We can change, I will tell you how to do that. So in sprite 2D we can change the flip edge, and in node 2D we can change the rotation. So how we can do that is, let's go to the parent where we can access it. So what I will do is we'll first get node, and I will say that in the current node, that is nothing but dot, what I want to do is I want to change the rotation degrees. What position? I'm just checking why it's not showing. Okay, so sometime it doesn't show. So what I can do is I can say rotation underscore degrees, and I can say, let's say it's two rotation degrees. Okay, and then what I can say is for this sprite 2D. So another instead, so you can do, instead of doing get node, there's a shortcut, is you can directly do this dollar symbol, and then you can write the sprite 2D directly. Another way to have is just directly drag it here. You get the name, and just now you can write is, let's say I want to change the flip edge to true. Okay, so it will flip it. Okay, so rotation degree is where things quite turn. So it basically rotates it, and yeah. So so this was all about this. So we also talked about some shortcuts also. So few more shortcuts I will be telling you later in this video, but this was number one. So you can just drag it the node and you can get it. Okay, so we have got this. Now let's see, let's come to another topic. That is, if we go back to the debugger, we can see something, it says delta all the time, and you don't know what is this, which we are going to talk about right now, and I will make sure that you know what delta is. So as I said, process is called every frame. Okay, and it says delta is the elapsed time since the previous frame. So first let's understand how these frames and all comes into the picture, and why we actually needed the frame. So I've prepared something for you, and I've highlighted something for you just to understand things quite better. Okay, so let's say you have added a speed to your character of 10 pixels. Okay, and let's say we have three sets of computer A, that is, let's say, like we have a, so what I say, a slow computer. Okay, so if you have playing game lately, you might know that slow computer have low fps, right? And we as a gamer wanted know that we don't want, what I say, low fps, we want high fps. So a computer B, which is of like 60 fps, it's okay. And then we have a computer D that is of 120 pixels. I don't know who is that. So something like this, he is very happy. So the reason why these guys become happy is because now I will tell you. So let's say you have built a game. Okay, and let's say you want to change the speed of this image by which it's moving, what I say, uh, by let's say by 10 pixels, right? So let's say if I have added this, so currently if you see it's moving 10 pixel by 10 pixels, it's moving down, okay? And if we increase it, it will move it. But now the problem is, with every frames per second which we have, in all these three computers, things might not work the same, because right now even if you have mentioned 10 pixels per frame, but it might not move the same. Now I tell you why. Because let's say a computer which is of low end generates 30 frames per second, okay? That is this one. And a computer B generates 60, and a computer C generates 120, okay? Now for each frame, like let's say per second, right? So by the time the what I say user moves to 10 the computer gets the instruction that I have to move to 10 pixels. What happens is, the original movement in all this computer view might get different. Let's say 10 into how many 10 is, are like per frame, right? 10 pixels per frame, and frames per second. So original movement is what we get is 300, okay? Because once, how many frames do you have? 30. And in those 30, how many frames are you pixels are you creating? 10. So 13 to 10, 300. So when you are moving, when the computer gets instruction that I want to move 10, but it actually moves 300 pixels. And similarly for the computer B, it moves 600 pixels. And in computer this, it moves by around 1200 pixels. And that provides very inconsistent player movements, right? And we had to solve this. Now how to solve this is where is the question, okay? Now let's imagine, the if we get what I say, the time, like let's say this 30 is what we get, right? And after this 30, let's say for creating for like rendering this pixels, 10 pixels for the 60 frames, and then getting the time of, like how much this time it took to generate uh, 10 or around 10 pixels per frame in 120 frames per second. If we get an average time, like what I say, a time for this which actually cancels each of them, we can get this. If we do the math, if we get what I say, a number, or what is a fraction of time, where we, if we actually cancel it, let's say if we do the math, if we cancel this 30, 60, 120, we get this 10 instead of this. So how we'll get that? So I'm revealing the first thing, that is where the delta time comes into the action. So let's say delta time is nothing but the seconds, what I say, the time lapsed between the previous frame to the current frame. This what it says by the definition, right? Since the previous frame. Now if we go back, so here, now if we do the math, now instead of, directly like how we are defining the time, right, speed, right? Now, instead of doing this, if I directly multiply it by delta, the speed, and if I reveal this also, so we will get 10, 10, 10. Because if you do the fraction, you will get this float values, right? And if you multiply it, you will always get the same value, 10. So this was the idea. Now but the catch here is one more. Now if I show, if we do this change in the game, and by the math, as it says that we should do the delta. If I want to make it 10, right? Let's imagine I have a delta of 0.1, let's approx. So if I give it 10, then it's generating me. So let's say I give it 600, then it can give me a good speed, I think so. So if I do it 600, and if I play it now, it might move like how it was moving previously. But this makes sure that in all these three computers which you see, uh, it will run the same speed, okay? Independent of what frames per second is. Because see, remember guys, why we actually came into this, because everyone wants an, what I say, our speed computer, right? And that's why so this was the what the user demand was, this FPS. So since we don't have a control on this, so that's why we have this, we have a control on delta. So that's why we are multiplying it, and we are getting the same value is what we needed. By the way, let's see you in the another video, guys. Let's create something nice, and in the next video I think I will be making how to get input. So see you there.